Welcome to the QuickBase Fundamental Skills module. The lessons in this module include essential QuickBase structure and data modeling, how to build an application, moving data between tables, the 3 ways to import data to your application, and basic formulas. Our first lesson will be essential QuickBase structure and data modeling. By the end of this lesson, you will be able to identify the 4 major components of QuickBase, match the major components to their position in the database hierarchy, describe the benefits of a relational database over a spreadsheet, define the key components of data modeling, explain how to model data for a particular use case, and identify the most efficient data model given a use case. In our first topic, we will be identifying the components of a QuickBase application and how they work together. Relational databases such as QuickBase are composed of 4 major components. Depending on your background, the terminology may change, but the idea remains the same. In QuickBase, these 4 components are referred to as tables, fields, relationships, and records. To build an efficient and useful application in QuickBase, you must understand what these components are and how they work together to manage your customers' data. The first component is tables, sometimes called entities. They correspond to something in the real world that is of interest and that you want to store information about. Examples could include things such as departments within an organization, employees, or sales receipts. Each specific department, employee, or sales receipt is considered an instance of that entity or a record on that table. The second component is fields, also referred to as columns or attributes. They represent information about a table that will be tracked. In the example of an employee, the Social Security number, birth date, or similar information could be set as a field on the employees table. The same could be said for company, where we might track an address or the website. The next component we need to speak about is records, also referred to as instances or rows. These correspond to the actual data being captured within the table. In the case of an employee, Leslie Jones, we might track her first name, last name, date of birth, and phone number. As you can see in this example, while first name, last name, date of birth, and phone number are the fields, the information or the record is actually Leslie Jones, 4/29/1970, with her phone number being 678-555-1212. If you are familiar with Microsoft Excel, you can relate these components in this way. The Excel file or workbook would correspond to the QuickBase application. Each worksheet within the workbook would correspond to a table within the application. Each column within the worksheet would correspond to a field on the table, and each row within the worksheet would correspond to a record on the table and would hold the data being tracked. Unlike Excel and other spreadsheet programs, however, relational databases like QuickBase allow for capturing data in a more efficient structure where data duplication is limited and where users can very easily make changes to a single piece of data, such as the name of a department, and have it propagate against any record that uses that data. Our fourth and final component of a QuickBase application, relationships, is what allows us this flexibility. Relationships allow developers to break the information that is being tracked into many tables so that it can be more easily managed and accessed. Relationships between tables allow you to store only that data which is unique to each record on a table. Data that records may have in common can be stored on related tables and accessed via the relationships between these tables. Relationships in QuickBase have two sides, a parent and a child. The parent table will have one record to the many records that are possible on the child table. This concludes our discussion of key QuickBase components. Next, we will take a look at the basics of data modeling. In this topic, we will be examining the basics of data modeling. Data modeling is the term used to reference the process of looking at data tracking requirements, such as marketing campaign results or project deadlines, and sifting through to determine the required tables, fields, and relationships as it applies to QuickBase and development in general. Records, though they are an integral part of the application, simply give us context during this part of the process. Many times, customers will provide examples of their data in a spreadsheet format similar to the layout shown here. In this example, the manner in which you structure your application and make certain changes, such as correcting a department number, will either set you up for success or failure. Based on this example, deleting all the employees in the purchasing department will eliminate the department itself. If you change the name of the marketing department to advertising, you would need to change the record of each employee in that department. All of this information, although appearing in different rows and columns, is related in some way. Relationships allow us to break down this data, or normalize it, so that we can end up with two tables that have fields that are unique to each. In this layout, we can see that department information has been given its own table, as has employee information. In addition, the employee table has retained the department number field, which will allow it to pull information about the department down to the employee table as needed. In QuickBase, this is known as a reference field, as it refers back to data in another table. When modeling data for an entire application, the steps are the same. However, it may require much more investigation into the business processes and data use requirements to design a data model that works for your client. To give you a better idea of how you might develop a model for a client, we are going to step through the process with this simple use case. Bob has a successful event planning business, but doesn't feel that he's doing as well at managing his expenses. Recently, Bob had a couple of very large events that should have had a much larger profit than what his bank account currently shows. Bob wants to be able to do more of these large events because he knows that the publicity for his business would be great. If he can't get control of his costs, however, he also knows that he'll be stuck doing the catering for the Arts and Crafts Club at the local library. Bob needs a data model design that will allow him to schedule his events, manage work leading up to each event, manage employees working each event, track employee hours, and see an overview of their costs. While we do not have specific data that needs to be tracked, we can assume that, for this example, Bob needs to track only the most basic of information within any table. In order to make this example a bit clearer, however, here are the data points, or fields, that we will be using. While we've identified the individual data points, we still need to group them into efficient data sets or tables, and then identify the relationships needed to meet our client's requirements. Much of this data will easily fall into the various tables, but I'm going to rearrange the fields so that they are properly grouped into their table sets. Now that we've completed this stage, we can see that we have identified 9 distinct tables from just this small number of fields. To accomplish our goal of building an efficient database, however, we still need to connect these tables with their appropriate relationships. In your mind, start developing the table hierarchy to make it easier to move the tables into a layout that will allow you to see the relationships clearly. Now that all of our tables are set in the general area where they will end up, begin to draw in the relationships. First, connect clients to contacts. Clients is going to be the parent table to our contacts table, so you will create an arrow pointing from clients to contacts. Repeat this process for the relationship between contacts and events, and then again for events to tasks, time cards, and expenses. Venues will be the parent table to events, and vendors to expenses. Employees will be the parent to 2 tables, tasks, and time cards. With this design, we have not only created a design that is efficient and does not duplicate data between tables, but one that meets or exceeds our clients' needs. This concludes our discussion of the QuickBase structure and basic data modeling. You should now be able to identify the 4 major components of QuickBase, match the major components to their position in the database hierarchy, describe the benefits of a relational database over a spreadsheet, define the key components of data modeling, explain how to model data for a particular use case, and identify the most efficient data model given a use case. Possessing a solid understanding of how to plan and set up a data model that seamlessly translates into a QuickBase application will inevitably help drive success for your clients and in turn for you as a QuickBase developer as you work to build a strong reputation and brand for yourself and your firm as a leading QuickBase solution provider.